Okay, class. So people are asking what should be the simulation of inverted pendulum look like. So I've been saying in class that it is unstable, but that's wrong. It's not unstable. So it depends on what are the initial conditions. For example, in this simulation, our parameter says the z is 1, that is the displacement, or y is 1, and point 2 is theta. And 0 0 velocities like y dot and theta dot are 0 0. So point 2 means around 10 degrees initial angle, right? So for that case, so to investigate that, I have added two scopes here, one for y and theta. We can see their plots. So let's run on how things look like. So you will see that's the initial condition. It goes here again, comes still here, the same position, comes back here, comes back again here, comes back again here. So it's not unstable, and you will see that because this moves, the torque is exerted on the cart also. The cart z also changes in this direction. Now let's see the plot for this y first. So you'll see that, as I said, your z also had a slight around a meter's movement, right? So your cart moves in this direction and this direction around a meter. And similar theta, so you can see theta starts at point 2, again goes crosses pi, and then again to the other side, comes back to point 2. Because there is no friction, it's kind of, it keeps repeating this sequence. So it's when I said it was unstable, I was wrong. It is stable, but um, it is not decaying. It's an oscillating. It makes sense, right? It oscillates. And cart also moves, because when the pendulum goes from one point to another point, your cart basically moves in one direction to the other direction. So yeah, we can change the initial condition and see if it changes anything. Let's make it 0.3, so it will be around 15 degrees. Let's see. So now it starts further off, right? So it will again, but so you see the cart is also moving slightly, but it is not unstable. Okay, let's see our y. Say, yeah, y moves again, similar motion. Theta moves again starts from point 3, but the oscillations, same motion will be repeated all the time. Okay, so yeah, that is how your simulation should look like.